talk about how to describe transformations of exponential functions. So remember that the parent function f of x equals b to the x, where b is bigger than 0 and it does not equal 1, is the parent function of the family of exponential functions. So let's look at an example where b equals 2, and let's talk about some transformations. So transformations of exponential functions, remember there are three types of transformations. We have shifts, which are translations, stretches and compressions, and we have reflections. So what we can do is we can change the values of a, b, h, and k, and those will create transformations. So we're going to use, just as reference, like 2 to the x as our parent function, and then we're going to think about the transformation. So an a in front, okay, that is going to create a vertical stretch or a compression, okay? So it's going to create a vertical stretch or compression, and then if it's less than 0, okay, if it's a negative number, it's also going to create a reflection. B, on the other hand, that is going to be a horizontal stretch or compression, okay, because B is being multiplied, so that's going to be a horizontal stretch or a compression, and it's also going to create a reflection if it is negative. When we have H, that is going to be our horizontal shift, okay, so that is going to be where the graph is scooted to the left or to the right. And then K is going to be a vertical shift. So that is going to move our graph up or down. Remember that the horizontal kind of does the opposite of what we think it'll do. So if it's going to go to the left, we're actually going to see a plus sign in this problem. And if it goes to the right, we're going to actually see a minus sign. Okay, if K is positive, vertical is going to do what we think it's going to do. So if it's going to be positive, it's going to go up, and then negative is going to go down. So this is all summarized right here in this chart that is also included in your study guide for transformations of exponential functions. So remember, you can also use this flow chart when you're solving these problems. So let's look at some examples. So notice here we have y equals 2 to the x as our parent function. And when we change that to 2 to the x plus 5, it's going to be shifted up 5 units. When it changes to 2 to the x minus 4, it's going to be shifted down. Okay, so changing the value of k is going to shift the graph up or down. So we have a horizontal translation when we change the value of h. So when h is positive, that means we're going to have a minus sign in our problem. That's going to move it to the right. When h is negative, which gives us a plus sign in our problem, the graph is going to move to the left. We can also have a vertical stretch or compression. When a is a number that's bigger than 1, the graph is going to be vertically stretched. So you can see this blue graph is actually taller than the original parent function. When a is less than 1, so for example, when a is 1/4, the graph is going to be vertically compressed. So it's going to be kind of flattened out. We can also have a horizontal stretch or compression. So when b is a number that's bigger than 1, the graph is going to be horizontally compressed, right? Remember, horizontally compressed is going to make the graph narrower. That's why it looks taller. And then when a is less than 1, the graph is going to be horizontally stretched. Okay, so that's why this graph is like wider. We can also have a reflection over the x-axis. If a is less than 0, if a is a negative number, then the graph is going to be reflected in the vertical direction, so it's going to be reflected over the x-axis. If b is less than 0, so if b is a negative number, the graph is going to be reflected over the y-axis. So let's try looking at some examples of equations and think about the transformation that occurs. So f of x is going to be some version of the parent function. Okay, so in this case, f of x is 3 to the x. So what we need to do is think about what happened in the transformed function, right? So in the transformed function, what we did is we added on this minus 3, okay? So let's use this flow chart. So is it inside or outside the exponent? Well, it's outside the exponent, so it's going to be a vertical change, right? We're subtracting that 3, so that tells us that we are going to have a shift down because that 3 is less than 0, okay? So this is going to move the graph down 3 units. Remember that you can confirm these changes by going to Desmos. So you can go to Desmos and you can enter the original function, 3 to the x, and then you can also enter 3 to the x, and then make sure you click out of the exponent to type in the minus 3, and you can see that it is in fact shifted down 3 units. Now let's describe the transformation that takes function f to function g. So notice we have 1/2 to the x, which is the parent function, and then in g we have this negative in front, right? So that is basically like we took that a and made it negative, right? This is the situation where a is less than 0. So that negative in front, that's the new part that we added in. It's on the outside, so it's going to be a vertical change. It's multiplying the function, and it is less than 0, right? So that is going to be a reflection over the x-axis, okay? Let's double check in Desmos. So let's go to our Desmos, and we type in 1/2. So do parentheses, and then 1 divided by 2. And then we put the exponent, so do caret x, and then we do negative, and then parentheses 1 divided by 2, and then you do the exponent, and then x, and then notice that it is in fact reflected over the x-axis. So always use Desmos to confirm when you're doing transformations questions. So now we have 4 to the x, that's our parent function, and then we have 2 times 4 to the x plus 3. So notice I actually have 2 things that got changed in this problem, right? I have this 2, and I also have this plus 3. So let's think about how these are going to affect our graph. Well, the 2 is on the outside, right? So that is going to be a vertical change. It's multiplying the function, and that is a number that is bigger than 1. Okay, so that 2 is going to be a vertical stretch. So when I use the flowchart to solve these problems, I have to start all over when I'm doing a new number. Okay, so when I'm thinking about the 3, I'm just going to go ahead and erase all of these and then just start all over. Okay, so I have a plus 3 now, which is on the outside of my function. It's being added or subtracted, and it is positive, right? So it's going to be a shift up. Okay, so we would say it's shift up 3 units. Okay, so now let's go to Desmos. So when we go to Desmos, we're going to clear what we have. So we have 4 to the x, and then we have 2 times 4 to the x plus 3. Okay, so what we said is that it's going to be vertically stretched and shifted up 3 units. So if we look at our graph, you can see that is in fact vertically stretched, right? If you zoom out, you can see that a little bit better. And it's also shifted up 3 units. So now you can go ahead and pause the video and try this example on your own. Okay, so let's think about what's new here. So we have a -3 in front. We have, okay, 6 to the x has not changed, and then we have a plus 1. Okay, so that -3 in front, okay, that's on the outside, so it's going to be a vertical change. It's being multiplied. It's a number that's bigger than 1, so it's going to have a vertical stretch, okay? But it's going to also have a second effect because there's a negative in front, okay? It's going to have a second effect, which is a reflection, okay? Because that a is not only bigger than 1, it's also less than 0. So we would say it is also reflected over the x-axis. Now we have this plus 1 at the end, okay? So this plus 1 at the end, what I'm going to do is I'm going to restart my flowchart. It's on the outside, okay? It's being added or subtracted, and it is bigger than 0. So we're going to say that plus 1 is going to be a shift up 1. Remember, you can always, as usual, use Desmos to verify. So let's clear this out. So we have 6 to the x, and then we have -3 times 6 to the x plus 1. So -3 times 6 to the x, and then click out of the exponent to do the plus 1. And you can see that is in fact vertically stretched, right? This graph is a lot narrower. It is reflected over the x-axis, and it is shifted up 1 unit. Okay, so just always double check your transformations in Desmos. So in summary, you're going to determine any transformations by figuring out whether the values of a, b, h, or k have transformed in the function equation. And then you're going to use this to identify the type of transformation that has occurred.